Hey everyone! Look around you. What do you see? Oh, that's too easy. Why do you see?
Well, we see because light bounces off all surfaces. Here, 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 here. And then it goes into our eyes, like how this particle. Boop, boop.
So you're saying light's a particle like this marble?
Hell yeah.
This marble is a particle.
Mm-hmm.
Well, I think it's like a wave. Sounds are waves. Waves bounce off surfaces and get absorbed by our ears and our eyes. So light is a wave.
Well, I disagree. I think it's a particle. Look, I have
Okay.
it set up here to show what particles are.
Alright, let's talk about particles then. Particles behave really predictably. So we have two slits here and dominoes represent where they hit. When we release the marbles,
You can see that they always hit these two where they are directly behind the slits that show that it moves in a straight line. That's how particles work.
so let's try it with light. Alright.
Two slits. See these? These are just like that.
Okay, so when you shine light through, it hits like a straight line. I mean it hits the sides which are most closest to the thing.
So it's a particle?
We'll see. But for now, let's talk about waves. Waves behave slightly differently. With one wave, you have one energy source and an ever-spreading wave. But with two slits, two waves. Like so. And as you can see from the shadows, they intersect. Those two waves intersect. And where they intersect is where they are most powerful because they support each other. They make each other more powerful. Where the places where it don't, they cancel each other out, so there's no energy. So places like in the middle and the sides, they are most powerful. And the middle, they have no energy. So this will create a pattern like this. A strong, weak, strong, weak, strong, weak kind of pattern. So let's try another experiment
On something else.
on a different light source.
It's called a laser.
Alright,
Okay.
here we have another setup. These are two very tiny slits, and this is a laser. What happens when we shine through it? Whoa.
What is that?
That is a light dark pattern. Just like the water waves.
Wait, I thought we just proved that it was a particle.
With the torch? Oh, we're so stupid. See, this torch right here, well, it's definitely not a good light source to use because this light source is incoherent. It has all wavelengths and all frequencies. It doesn't move equally. But laser, it's concise, it's focused. So it has equal amount of wavelength and frequency.
Which makes it red. Only one wavelength has the red color.
Yeah, laser is true light, not this. This is not correct. This is trash.
But I still disagree that it's a wave. I think I have another experiment to show that.
Okay.
But first we have this little thing over here.
Alright, this is called an electroscope. Aluminum foil, aluminum flaps. So let's talk about static electricity. Well, there are two types, positive charges and negative charges. When a thing has an equal amount of both, it's said to be in a neutral state. So let's exchange some particles here.
Okay.
Alright, when we do this, the rod gets negatively charged. So,
More electrons are traveled into the rod.
Alright.
But when we touch this electroscope, the electrons repel the electrons on here and moves it down into the aluminum flaps.
So, because it's so light, it repels each other because there's so much negative energy inside it. It repels.
Why are we showing this?
Well, because light has a very popular and amazing characteristic. When we shine light on a surface, it ejects electrons. Electrons are negatively charged. So when we do this, it will neutralize it because it will reduce the amount of negative energy inside.
As we go
this.
closer, the light will automatically
Make it go. It will neutralize it until eventually it will close up.
Side note, that's how
Solar panels
work.
Solar panels use this system to produce electricity, but it only happens when it's a particle. When it's a wave, it's not possible, right?
Wait, is it a particle or a wave now? You know what? I'll just call it a wavicle.
Hey guys, we're the quantum mechanics. Thanks so much for watching. We hope you've learned a lot from this video, and we hope that we have given you a good experience. And thanks for watching!